Salam alaikum. Good morning, everybody. So, I'm a product manager in EPTA. EPTA is a company dedicated to commercial refrigeration for a very long time. I will present you the transition to non-synthetic refrigerant. In 2007, in Europe, there were the will to protect the planet and to protect the next generation, and into act, it was decided to implement the F-gas regulation. This regulation forced us to abandon the HFC refrigerant. There were no synthetic refrigerant available with low GWP and also non-flammable. So we were forced to use the CO2 in a remote cabinet and a centralized refrigeration installation. And we discovered all the benefits of the CO2. It's non-flammable, it's very stable molecule, it's very cheap, it's available everywhere, and it's a long-term refrigerant. For plug-in cabinets, we decided to use the propane because with a very low charge of propane, we can use a flammable refrigerant, but with safety because we use under 150 grams only. So on this picture, you can see that in the last 5 years, the CO2 transcritical is becoming the dominant design for commercial refrigeration. Especially in Europe, we produce 100% of packs now with CO2 in our factory. Last year, we built our last HFC pack. We also promote this technology in North America, in Australia, in South America. We can see that in most of the many parts of the world now, the CO2 is dominating the refrigeration market. We had some innovation on CO2 transcritical. The goals were to have more efficiency on the standard CO2 transcritical systems, and also to be able to provide CO2 transcritical also in very hot climates. At the beginning, it was not possible. So the first solution we implemented was in 2017, and the name is FTE. FTE is a very simple solution that has the benefit that we can decrease the consumption of a standard CO2 system. The first FTE was released in 2017. There were a second version in 2020. And now this year we implemented the last version of the FTE system. We call it the FTE 3.0. In 2020, we implemented another very smart solution. We call it ETE. And the idea was to push the CO2 transcritical in very hot climates. Because at the beginning, it was easy to install CO2 transcritical in cold climates, but not in hot climates. We faced some issue. And with the implementation of this new solution, we were able to deliver CO2 transcritical in south of Spain, south of Italy, but also in Australia, Africa, and also in Middle East. So this is the solution, the integrated subcooling. We call it ETE. This is a system, very simple, very smart. As you see on the picture, between the gas cooler and the transcritical valve, we insert a plated exchanger. We take some CO2 on the high pressure side. We pass through an expansion valve, and there is a dedicated stage of cooling compressor. We call it ETE compressor. And the effect is the subcooling of the outlet of the gas cooler. It's like if we create a microclimate after the gas cooler. So when we have a temperature, for example, of 43 external temperature, the outlet of the gas cooler will be 45, And with the subcooler, we can reach 35 degrees, 30, 25, depending on the load of the installation. And this very simple solution permits us to bring the CO2 transcritical in very hot climates and without the use of water. And it was very interesting for us because at the beginning, we use spray system because it was the simple solution to bring the CO2 in hot climates. But when we have hot temperature, many times we don't have water available. So with the ETE solution, we can bring the CO2 in very hot climates with very good results and good efficiency. This is the presentation of another solution. The full transcritical efficiency, we call it the FTE. The FTE is based on overfeeding of air evaporator. We introduce a very simple component existing from the beginning of the refrigeration, and it's an anti-liquid bottle. We see that moving from dry expansion to, let's say, fluided evaporator, we can increase the evaporating temperature from 4 to 6 degrees, and we can reduce the consumption of the system from 10 to 15%. With just adding a component which is anti-liquid bottle. Anti-liquid bottle is usually used for protecting the compressor. So we use a safety device to increase efficiency. And this is possible because the properties of the CO2 permit this. This solution was the last version, is not the last version, it's the FTE 2.0 from 2020. Now this is the last version delivered this year. We not only have the overfeeding on empty evaporator, but also on LT evaporator. So we can increase of about 3% the yearly consumption of the pack, just adding a plated exchanger and subcooling the liquid line and overfeeding the LT evaporators. So with the ETE solution and the FTE solution, we are now able to deliver CO2 packs in hot climates in a very efficient way and very reliable solution. This is the complete range of the packs we have in our portfolio in EPTA. So we start with very small condensing unit with CO2 at 1 kilowatt, and we can reach 450 kilowatt, 500 kilowatt with our range, because our range is around supermarket. We deliver the ETE solution and the FTE solution starting at the Eco Small Plus, so that means for beginning at 40 kilowatt, very small supermarket. I wanted to take as an example the Australian market because I think it could be in parallel of the climate we can find here in Middle East. At the beginning, there were a new regulation in 2007, the National Greenhouse and Energy Reporting Act. And this implies to use very low GWP on refrigerant. So the first CO2 transcritical plant was done in 2007. We introduced also the subcooling because it was the previous version of the integrated subcooling. And this solution was very easy to install, and we promote that in 2014. The first ETE solution, so the integrated subcooler, was tested for the first time in 2018. In 2024, we also integrated the air conditioning on the CO2 pack in a very efficient way. And now we have more than 60 plants in Australia with ETE on board. Not only in Australia, but also New Zealand pushed a lot for CO2 transcritical installation. And now we can say that it will become the dominant design also there. I wanted to point out this interesting story because I think there is, you can face the same issue of high temperature. In Australia, we can face 48, 49 external temperature. And we have delivered a CO2 system in a very reliable way. So I think it's totally possible also to do it here in Middle East. As an example, we made our first plant with CO2 transcritical in Middle East, in Abu Dhabi in 2019. And since today, we face no issue. We wanted to make a short comparison between several technologies. So, on this graphic, we made a calculation of a very standard direct expansion 404, another direct expansion 448, the CO2 with ETE, because ETE is our standard for hot climates, so we directly put this technology in our graphic. And also the most advanced solution, ETE plus ETE, plus FTE. So we make calculation for, depending on the external temperature, and here are the results. About energy consumption, the worst solution, let's say, is the 404. We have same level of consumption with the CO2 and ETE. So if we take the best version is the ETE plus the FTE. It's when we reach the best consumption. The margin between the 404 and the best solution is 10%, so it's not a few. And we can say that CO2 is equivalent, CO2 with ETE is equivalent to the 404, and FTE plus ETE is equivalent to 448 in terms of consumption. If we have a look of the total cost of ownership for the next 12 years, there is a huge difference between the best solution and the worst one, 16%. It's not a few. So in this case, the worst one is 404, the second one 448. We can reach a very good result with the standard CO2 pack with ETE, and the best performance, of course, with the FTE and ETE. The last graphic maybe is the most interesting. It's the TWE. TWE is the total equivalent warming impact. So we integrated in the calculation the direct emission, so the leaks, let's say, leaks of refrigerant, around 50% per year of the total load. And we integrate also the consumption and the energy, the carbon emission linked to the consumption. In this case, we see that there is a huge difference between the natural refrigerant, the CO2, and the synthetic refrigerant, more than 200%. It's a lot, it's huge. So even if the first figure, we can say that, okay, CO2 and synthetic refrigerant can be equivalent. When we see the TWE, it's not at all. So the conclusion of this drawing is say that in terms of consumption, CO2 is reliable in warm countries. In terms of cost, of saving money, it's interesting too. And the last point, the impact on the carbon footprint of the full installation, there is no other word that saying that CO2 is the way to adopt. So how make the transition? As it was already said in the discussion before, the first step is to invest on people, not invest on equipment, invest on people. Make trainings for engineers, training for technicians, because it's the different solution. It's not very standard refrigeration, but with the knowledge, it's possible to spread the solution. The second step is to conduct some field tests and also to permit you to choose what is your favorite technology, what is your favorite solution in terms of cost, efficiency, reliability, easy maintenance. There are many parameters, and with testing all the technologies, you will choose your best one. And then the first step is to spread it widely. Of course, we will remain at your disposal because we have very few time to present all these slides, but it was a pleasure to be there, and thank you very much for your attention.